Well, how are you guys? How are you doing? Today we are going to learn about the laptop chips voltages, right? Yes. So, as you can see here, I have some diagrams representing some chipsets or the chips. When you see the chips, this one represents the chipsets. First, here you have the CPU. The CPU, this is the central processing unit of your motherboard or your laptop. Actually, this is the brain. This is the brain of your computer, right? Yes. So you can see we have the voltages we call VCC core, which is approximately one voltage. Then you have another one called VCCB. So these are the operation voltages for the CPU. So your processor or your CPU needs these voltages for operation. Then you have what is called the VTT. See, this is the voltage for the terminal or terminating voltages, which is about 0.8 voltage. So those are the voltage you need to have in your processor. I'll show you a diagram having these circuits which generates these voltages. Then here you have what's called MCH. This is the node bridge. The node bridge, this is the chipset which controls the CPU, which ensures that the CPU communicates with the peripherals. And the peripherals here about the node bridge, you're talking about the high-speed component. So node bridge ensures that the CPU speaks with the high-speed components like RAM or the SSD or the hard disk drive, right? Yes. So this is the node bridge, and the node bridge requires 1.8 voltage, 3.3 voltage, and 1.5 voltage, either 1.5 or 1.05. So these are the voltages which are required by the node bridge for it to operate. So we don't need only one voltage, we need a lot of voltages inside these chipsets because they does a lot of work. So same case applied to the CPU. That's why in the CPU we have one voltage, 1.05, and then 0.8 for the FICO voltage. For the node bridge, same case, you need 1.05 or 1.5, 1.8, and 3.3 voltage. So whenever you are diagnosing your laptop motherboard, you ensure that you get these voltages in your CPU. And again, however, these voltages can only appear when your laptop is on. Yes, when your laptop is off, you cannot see these voltages. You will find that at the circuits which should generate these voltages are generating zero voltage. Not until you switch on your computer, that is when you will start seeing those voltages. Then here you have the ICH. The ICH is part of the processor. Same case with the node bridge. They are all included inside the CPU, or they are part of the main chipsets into your motherboard. And the south bridge, this one is responsible for controlling all the input output devices, that is the audio ports, the USB ports, the HDMI, the sound, the network. So it is the responsibility of this south bridge to ensure that those devices communicates with the CPU. And this south bridge needs 1.05 voltage for the VCCB, right? 3.3 and 5. So the reason we need 5 here is because it will control those ports, the USB ports, the HDMI ports. Yes, this ICH stands for input control hub. And the node bridge and the south bridge are all included in one chipset called PCH, that is platform control hub, right? Yes. And then you have another chipset here. This is called KPC or the SIO. This is super IO. We call it super input output. So this chipset uses 3.3 voltage. So around this chipset, you will find a lot of voltages either coming in or going out from these chips, from this IC, at 3.3 voltage. Why? Because most of the operations which uses this 3.3 are conducted by this IC, right? Yes. Then again, you find that you have what is called DDR1. So this is a RAM stick. So this is the RAM, that's the memory for the CPU. DDR1 uses 2.5 VDD, this operating voltage 2.5. Then the voltage for termination, that is a terminating voltage, is 1.25. That's actually the half of the VDD. You'll get the terminating voltage, which is 1.25. And then you have the speed, the voltage for speed, that is 3.3. Same case applies with other RAMs, all the DDRs, that is DDR1, DDR2, DDR3, DDR4, DDR3L, DDR5, all of them needs 3.3 SPD voltage. And then other than that, you have this one called VDD, it varies. So the VDD voltages for different RAMs varies. Depending on which DDR you're talking about, it has a different voltage operation, and then VTT are different. For example, DDR2 uses 1.8 voltage. This one uses 2.5. This one 1.8. You know, over time, the manufacturer decides to modify this DDR to use less power. So the DDR1, this is the oldest DDR. That is why it was using a lot of power. DDR2, they improved a little bit to 1.8. DDR3, they improved again from DDR2. Instead of 1.5, 1.8, they improved to 1.5. So it uses lesser power than DDR2. Same case with DDR3L, still they improved. So DDR3L and DDR3, their difference is the speed. So DDR3 has less speed than DDR3L, which has more speed. Thus, this one can use less power as compared to DDR3. As you can see, the VDD voltage for DDR2 is 1.8. Then the voltage for terminator, that is VTT, is 0.9, half of this one. Same case applies to this one. A half of 1.5 is 0.75. A half of 1.35 is 0.65. Then I don't have another diagram here for DDR4. DDR4 uses 1.2 for the VDD, then uses 0.6 for VTT, and still SPD is 3.3. For DDR5, that's the latest. So the DDR5 are found in most of the latest laptops. So they have DDR5 RAM stick. So that one now, instead of 1.2 for DDR4, that one uses 1.1 voltage for VDD and 0.55 for VTT, and the speed obvious is 3.3. Alright, yes. Then the voltage in for the LCD or LED is 3.3. So whenever you have an LED light in your motherboard or in your laptop, just know those lights uses 3.3 voltage. Again, let's proceed. You have what's called LAN. So this is the Wi-Fi card. It uses 3.3. So Wi-Fi card uses 3.3 voltage. The BIOS chip. At pin number 4 and 8, you will get 3.3 in your BIOS chip. So if you test the voltage at your BIOS chip, you will get 3.3. When you don't have these voltages, for example, with this Wi-Fi card, if you are missing 3.3, that card might not work. It won't even work. Same case with the BIOS. USB-C, or USB is actually the USB ports. They uses 5 voltage. Card reader 3.3, clock 3.3. Then you have HDD. This is the hard disk drive or SSD. They uses 5 voltage and 3.3 voltage, so it needs the two. You have a fan. This is a fan, 5 voltage. Audio needs 5 voltage and 3.3 voltage. Thermo 3.3, and then the DVD player 5. Right? Yes. So I believe, guys, you've understood here. This is a summary. So you have Core i3 processor, i5 and i7. Let's see the difference. So this is i3. Then you have So this is the GPU. This is the GPU chipset. So the GPU's chipset, you have the graphics core voltage, that's 1.1, operating voltage 1.8. Then it also needs 1.5 voltage, that is for the graphics card. For the processor, that is i3, i5, i7, it needs the physical. This is called physical. This is the internal voltage which is used by the internal components inside that CPU. Then you have integrated graphics. That is when you have integrated graphics. You know, you have two types of graphics. You have what's called dedicated graphics, which this one, which is independent. It is actually only dedicated for to do the work of graphics. Then some other laptops might be missing dedicated graphics, but they do have integrated graphics. That is a graphics inside the CPU. That is why we call a graphics core. Then it needs 1.05 voltage and then 1.5 voltage. In that case, you have what's called the BCH. The BCH, I told you earlier, this is the combination of NOT bridge and South bridge. And I said the NOT bridge is responsible for ensuring that the CPU communicates with high-speed components, that is RAM and the SSD. While in the other hand, the South bridge is responsible for driving the ports. It ensures it controls the USB ports and the audio ports, the Wi-Fi cards or the Bluetooth cards. So that's the role of the South bridge, right? So I believe so far at least you've understood something about the voltages. So whenever you are diagnosing your laptop, if it is a laptop using DDR3, for example, so you need to ensure that your CPU has these voltages. That is when your laptop is on. Maybe you're missing the display, or you miss it. There's something wrong with your laptop. Maybe its powers on and goes off after some time, or shuts down unexpectedly. So you need to check for these voltages for the CPU. You have to check for the voltages for the this is a PCH. Let me just combine the two of them, the North bridge and South bridge. If they are together, you check the voltages here. That is 1.5, 1.8, 3.3, all of these voltages. Again, if it was if you're using DDR3, you ensure then your RAM has these voltages 1.5, 0.7. Yes. If you are handling the case of fan error, for example, ensure that your fan terminal positive terminals have high voltage. If it is about the sound, you check the audio IC whether it has these voltages. What else? If it is failed USB, you check if there are these voltages. If it is about the display, you check the BIOS if it is receiving power, that is 3.3. If it is about the Wi-Fi card or Wi-Fi or internet connection, you check for this, right? Yes, so those are the very important voltages you need to check out before you decide otherwise. Yes, before even you start removing BIOS or programming BIOS or removing the chips or card readers or the fan. You know, someone might decide to buy a new fan without even these things. The reason why we need to understand is because sometimes you might end up buying unnecessary things. For example, maybe you have an issue of a fan error. If you don't understand that fan error, that fan needs this 5 voltage for it to spin, you will end up buying a new fan. Of course, it will be a loss for you because you will end up having a new fan, but still it's not spinning or it's not working. Why? Because you have a problem with your motherboard. So first, before you decide to buy a new component, or before you decide to replace that component, you find out the reason why that component is not functioning, right? Yes. So guys, thank you so much for watching this video, and please subscribe to our channel and share with your friends. Thank you. Goodbye. See you in the next video.